My ant pathfinding system for Unreal Engine allows the player and AI's free movement over the map, ceilings, walls, tunnels, places you can't walk using Unreal Engine's nav mesh. It does so by first noting which meshes were marked for traversal by the game creator in the editor. It then pulls those meshes data from GPU buffers at runtime. Triangles along mesh intersections are then taken into a new buffer to be worked on in a multi-step process. The intersections are chained together, the tri-points that are inside of the meshes are ignored, and the remaining points are turned into new polygons. Those polygons then form the basis for a new set of triangles, which are then reassimilated so the end product is a single, mostly continuous mesh. The mesh is used to orient the ants in their movement and their rotation. And it's also used to generate the nav mesh, which can be seen here serving 100 ants pretty quickly. In a very early build, collision was ignored and ants passed through each other. At this stage, collision isn't exactly perfect. It is what it needs to be for the demonstration. In any case, ants playing bumper cars with each other isn't any more fun to look at than seeing them slide through each other like Pac-Man ghosts, so they do need collision avoidance systems. System A is ant-on-ant collision avoidance. Every nearby ant pair forms a bidirectional relationship in which one ant takes responsibility for avoiding potential collisions, and the other ignores responsibility. They just keep moving. In the one-on-one situations, ants rarely run into each other, but in large groups they still get a little bit bumpy. System B is ant on static mesh collision avoidance. Ants are constantly dropping a trail of breadcrumbs since their last cleared waypoint. Ants do this because if one ant steers away from another ant to avoid collision, it may steer itself right into a rock wall. When the ant notices it's about to bump a wall, it just retraces its steps to the last cleared waypoint and continues its journey. There are a handful of other small subsystems to cheaply resolve small issues while also, hopefully, more closely emulating ant behavior. Those details can be seen and read about in the source code. I can think of at least 100 ways this project can be improved, such as the nav mesh nodes should be spatially and parametrically normalized, rather than just being the vertices of the original meshes, plus the vertices added at the mesh stitching phase. There also doesn't need to be so much searching for node destinations. Things should just always know where their nearest node is. Ants should never do this. They don't do it that much anymore, but if you play the demo, you might catch some ants flipping out over the fact that their waypoint is buried inside a mesh. There are at least 100 ways this could be improved, but part of the point of this project is to show what I'm able to do in a month when I'm pushing into new territory. I hope this video demonstrates the future usefulness of this technology as a plugin for Unreal Engine, as well as my desire to never stop learning and doing difficult things.